Hello students, myself Professor Ankur. I welcome all for the gate theory session on the main topic of analog circuits. Today we are going to start an important topic, that is BJT introduction. We are going for the first part of the topic BJT. So before we actually understand the circuits of BJT, we will try to see what is the basic understanding of the device. So BJT is bipolar junction transistor. It's a device with three regions. One is NPN, other one is PNP, and there are two junctions involved in that, JBE and JBC. So this device was actually designed so that we can operate the device as an amplifier. It exists in two categories, NPN and PNP. So if you look at the figure carefully, the left hand side figure is basically a PNP transistor and a right hand side figure is an NPN transistor. If you observe carefully, the direction of emitter current is incoming for PNP transistor and it is outgoing for an NPN transistor. So if emitter current is incoming for a PNP transistor, the base current and the collector current will be outgoing, and if the emitter current is outgoing for an NPN transistor, the base current and collector current will be incoming. There will be two junctions. A PN junction is existing between a P region and an N region. So since we are going to get two combinations of P and N, there will be two junctions, one between the base emitter and the other between the base collector. When we talk about the configuration, the device is having three terminals. So when you talk about a network arrangement, one terminal of the network will work like an input terminal, the other terminal of the network will work like an output terminal, and the third terminal of the network is common terminal. So once you fix the transistor inside a network, one of the terminals of the device will work like an input terminal, the other terminal will work like an output terminal, and the third left out terminal will be defined as a common terminal. Whenever we talk about a specific configuration, the terminal which is not used as an input or as an output is defined as common terminal. So now we are discussing common base configuration. If you observe the common base configuration, the emitter terminal is working as an input terminal, the collector is working as an output terminal, and the base is working like a common terminal for both input as well as output side. If you observe the direction of emitter current, the emitter current is coming out of the terminal. So if you try to get confused with respect to the concept of input, because the input current is assumed to be incoming current for a network. With that logic, if you try to just get a small understanding regarding the input terminal, there is a confusion. But whenever we talk about the configurations, we never look at the terminal current is incoming or outgoing. We are just checking which terminal is the input side, which terminal is the output side, and it is independent of the direction of current. So from that logic, we can see here clearly that emitter is working like an input terminal, collector is working like an output terminal, and the base is working like a common terminal. With that understanding, the input voltage will be defined as VBE or VEB. So the input voltage is VEB here and not VBE. Input current is going to be IE. Output voltage is going to be VCB and not VBC. And output current is going to be IC. So I'll repeat. The input voltage will be VEB and not VBE, which is our normal understanding. Input current is going to be IC. Output voltage is going to be VCB and output current is going to be IC. There are two junctions, one junction between base emitter and one junction between base collector. The base emitter junction is always kept forward bias and the base collector junction is always kept reverse bias. This is the basic requirement of the device to operate as an amplifier. This will keep the device in the active region. Now, because of the impact of forward biasing and the reverse biasing, we have a small understanding or analogy for a diode. Whenever a PN junction becomes reverse bias, the potential barrier will increase. And whenever a base emitter junction here is made forward bias, this is as good as a PN junction, the base emitter junction will narrow down, or you can say even come to zero during the operation mode. So with that logic, we need to understand that whenever the base emitter junction is becoming forward bias, the PN junction will either be narrow or will be non-existing depending on the voltage applied, as well as the base collector junction will have a higher width because it is made reverse bias. When I try to get the current, I can define for the configuration IC is alpha times IE, where alpha is IC by IE. So now when I see IC equal to alpha times IE, I can see a small contribution ICBO. Now what is this contribution? This contribution is defined as the leakage current or the reverse saturation current between the collector and the base when the emitter terminal is kept open. And that's the reason it is defined as ICBO. Now what is that understanding? The understanding is very simple. You eliminate the input battery and you keep the output battery active. So the output battery will make the base collector junction reverse bias. So automatically the current that is going to flow inside the device or in the base collector region, it will be the reverse saturation current of the diode. So when you try to get the same analogy with respect to a transistor PN junction, that current will be defined as ICBO because that current is current flowing between collector and base when the emitter terminal is kept open. Now we are trying to understand the characteristics. So when we talk about characteristics, we are having input characteristics and output characteristics. So what do you mean by input characteristics? Input characteristics is basically a relation between the input parameters, input voltage and input current. Since we are discussing the common base configuration, the input current is IE and the input voltage is VEB. And when we talk about the output characteristics, it's a relation between output parameters. So the output current here is IC and the output voltage is VCB. But if your observation is sharp, the device is biased with respect to two batteries. So there are two conditions. One is input condition and one is output condition. So whenever we are trying to analyze a particular side, like we are trying to analyze the input side, that time the output side impact will be constant. And that's the reason for getting the readings of IE versus VEB, we are trying to keep the voltage value of VCB to a fixed value. And on similar lines, when you try to take a reading for the output side, where the relation is between IC and VCB, that time the input parameter, emitter current, will be kept constant. So you will be continuously varying the value of VCB and you will be noting the value of IC for a fixed value of IE. So when you try to get the relation, and when you can see the graph now clearly, the graph is actually showing the input characteristics is basically resembling the impact of a diode under forward bias. And that's the reason when the VEB value is increasing, the IE value will increase. And if your observation is sharp, the conduction is happening, the current is rising after a particular point. So this is as good as the forward characteristics of a PN junction. And when we try to see IC versus VCB, so for every rise in IE, you are getting a rise in IC. As soon as you get the value of VCB rising, you will find that the IC is almost constant for that particular value. But whenever the IE increases, the value of IC increases. So this is basically trying to reflect or resemble an impact of a diode under reverse bias. So this is the small understanding regarding the introduction for the BJT device and the common base configuration. Thank you.